You've heard me say before that back in the day I went to high school and I had such an amazing math teacher, Mr. Brace, and he used to tell us, oh, you gotta lock yourself in a closet. Think about this stuff. You're not doing that. Because you do, with this particular content, need to lock yourself in a closet and think about this stuff. It's just not, it's not that it's difficult. It's difficult to see. But once you see it, it all makes sense. But you're not going to see it through casual inquiry. It's going to take some digestion on your part. You're going to have to roll your sleeves up, get your hands dirty, chew on the material, work through it, and then the little light bulb will go off. And when the little light bulb goes off, you're in really good shape. So my advice to you, I know we have a 4-day weekend coming up. And what I would suggest that you do is both tomorrow or tonight and Monday night, I would get out the quiz I just returned to you, plus Monday's quiz. I would redo any questions I got wrong. And then I would go watch the videos, which I have to put up today. And I would go through and make sure that I could get them correct. That would be my plan of attack. And then when we get back on Tuesday, we take the third in a series of quizzes. And at that point, I believe that you can get the high grade that you want to get. The problem that I foresee is people basically walking out of the door today, be it 3 o'clock or 5 o'clock or whenever your practice and school responsibilities are done, and you're not thinking about school until Tuesday morning. And if you do that, you will not do well on Tuesday's quiz, and then you will suffer. And we don't want you to suffer. We want you to do well. I would be thankful for this. What we have discovered is that, be it through my teaching or your learning or a combination thereof, however it goes, you're not understanding how to do numbers 2 and 3 on these quizzes. And you need to work your way through it. You need to digest it, roll your sleeves up, get to work. So, without any further ado, let's take a look at number 1, which most of you got right. I would say 80% or more got it right. Write a recursively defined sequence. That means you tell me what a sub 1 is, or f of 1 in this case, and then you tell me the rule, whose first term is 7 and whose common difference is 5. So if you look at those choices, immediately, just based on the fact that the first term is 7, it can only be 2 of those choices. Which 2 choices could it possibly be based on the first term being 7? 2 and 4, good. Now, which one has a common difference of 5? 2. Choice 4 does not have a common difference of 5. It has a common multiple of 5. Now, I know the word difference means to subtract, and this says plus 5, but you've got to remember, you would be adding 5 from term to term to term, which means if you were to subtract them, hence the word difference, you would get 5. Okay, so number 1 is, as we just said, choice 2. Now we get to the ones that you're having a most difficult time with. So here is a recursively defined sequence. F of 0 is 4. So we have the 0th term, the first term, and the second term. And the 0th term is 4. Do we all agree with that? Yes. Okay. Now we need to find the first term. We've mentioned this many, many, many other times, and I cannot say it a different way. There is no other way to say it. This is where you need to lock yourself in a closet, and you need to process this until the little light bulb goes off and you say, oh, that's it? Because it is that simple once you get that. Look, the new term, f of n plus 1, or a sub n plus 1, which we sometimes use that notation, is -3 times the old or previous term plus 3. So it's -3 times the previous term. And you have to understand that f of n is the previous term. Remember what we said the other day. If I have blah, 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 n blah, 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 blah. What term is before n? N minus 1. It's the n minus 1th term. What's the term after the n term? The n plus 1 term. Now, this is n plus 1. This is n. So the new term is the previous term, because this n and n plus 1 could be anywhere on the list. It could be the first 2 terms. It could be the last 2 terms. It could be any 2 terms in between. What I can guarantee you is the n plus 1th term is always the term that is directly after the nth term. So the new term, here it is negative 3 times the previous term plus 3. Okay, so here's the previous term. So this is the 0th term, this is the first term. N is 0, n plus 1 is 1. Or the new term is the previous term, which is 4, times negative 3. What's negative 3 times 4? Negative 12 plus 3. And what's negative 12 plus 3? Negative 9. Then I take that term and I plug it in. What's negative 3 times negative 9? 27 plus 3? 30. Is that the same question that was on your quiz? Yeah, okay, good. All right, for some reason I was having a brain cramp, not remembering it. What?
I should have gotten 100.
Did I misgrade that one?
Yes.
Okay, so show me it in a couple of minutes. Well, when we get a down moment, and I'll adjust it to the thing. For some reason I was remembering something different. Okay, next one. F of 1 is 4. So here we have the first term, the second term, the third term, the fourth term, the fifth term. Perhaps it helps you to write that out. Now, let's plug in, what's the first term going to be, everybody? 4. Now, I'll tell you what this is not saying, boys. This is not saying plug a 5 in here. Which is, I think, what some of you think it's saying. It's not. If I gave you something that looked like this, f of x equals 2x plus 1, what is f of 5? That means plug a 5 in. Everything is context. In that context, yes, you plug in the 5. In the context of a recursive formula, n and n minus 1 mean 2 consecutive terms. And the n term would be the new term, and the n minus 1 would be the previous term. Or I could have said the n plus 1 would be the new term, and the n is the previous term. Now, this is 2 times the previous term. So I plug in the 4. What's 2 times 4? 8 plus 7. 15. Good. Now I'm going to plug in the 15. 2 times 15 plus 7. Now I'm going to plug in the 37. 2 times 37. 74 plus 7. 81. Now I'm going to plug in the 81. 2 times 81. 162 plus 7. 169. Okay? Now, again, I think it's very, very, very important that I don't think those two things are very hard. And I think based on the notes that we just explained to you, we were able to really address how more methodically to come up with the correct answers. And we were also able to address something I did not say yesterday, is that this does not mean plug a 5 in for n. Okay? So if you go home and again, roll up your sleeves, work on it, get your hands dirty, chew on this stuff, you'll get it. If you don't, you won't. Next, for which value is p plus w an irrational number? It's going to be, I believe, choice 2 because the square root of 7 you can't do. All right, that's the one that's irrational. Okay, any questions about that? No. All right. So, I was watching last night. Does anybody here get the Smithsonian Channel? The Smithsonian Channel. What is the Smithsonian? What? Yeah, it's an amazing museum, one of the best museums in the world. And it's all wrapped up in science and history and that kind of thing. It's for to become smarter, all things associated with the Smithsonian. And they're running a series this month of 1-hour programs on 4 baseball legends. Hank Aaron, Lou Gehrig, Babe Ruth, and Ted Williams. And they were talking about Ted Williams last night. I'm about halfway through the show. Emily, who else plays softball? Julia? Okay. I said Emily. Oh, Phoebe. What, do you remember last year we talked about tight zone, medium zone, strike zone?
Yeah.
And I said to you when we started that, the whole series of lessons on that there was this great hitter by the name of Ted Williams, and he wrote a book called The Science of Hitting, and on the front of the cover was him in his batting stance, and then there was a strike zone, and it was filled with baseballs. And as you looked at those baseballs, his batting average on every one of those pitches was listed on the baseballs. And they talked last night about how he had this relentless pursuit of perfection. All he ever did from the minute he showed up at the game until the minute he went home, and then even when he went home, they said he was so psychotic for becoming a great hitter that he would stand in front of the mirror for hours at home saying, I am Ted Williams. I am the best booping baseball player who has ever lived, the best hitter ever. And he would just watch himself swing into the mirror, working for the constant perfect swing, the perfect swing, the perfect swing. Now, I am not suggesting you go home tonight and go, I am Christina Rowland, the greatest mathematics student who has ever lived. I can take any pen. I can write perfectly. I can get every question right. I'm strongly not suggesting you do that. However, I do think you can apply yourself. Here's the thing I'm looking for. If Ted Williams swung and missed a pitch, by the way, Ted Williams is the last living baseball player to ever hit 400. Okay? If Ted Williams swung and missed a pitch, he would go through what he did wrong all the time. If you got questions 2 and 3 wrong on the quiz, you probably got similar ones wrong yesterday. You need to go home and ask yourself, why did I get that wrong? How do I straighten it out? That's the purpose behind this. And that part of your math learning, I cannot help you with. I can if you come to extra help. But I can't, like, pull up at your house and go, Jollies, put down the rap, let's do some math. That's not happening, all right? So this burden is on you, and you have to find a way to get it done. Okay. So we're working more and more on modeling context from sequences and from everything else. Identify the type of function that each table represents. Table A, what kind of function is this? Linear, very good. How did you know this is a linear function? Goes up by a constant amount. If I looked at this just as a sequence of 5, 7, 9, 11, 13, what kind of sequence would that be? What was that? Arithmetic, right? Because it's going common difference. All right, next one. 6, 9, 13.5, 20.25, 30.375. What kind of function is that? It is exponential. Now, you might have said to yourself, how can you confirm that this is exponential? How can you confirm that this is exponential? Hint, it has something to do with your calculator. How do you confirm?
Divide 6.
It could go either way, but it's just easier to do 9 divided by 6, 13.5 divided by 9. In other words, always divide new term by previous term, just like in the work we just did a minute ago. And then what about 3, 12, 27, 48, 75? What do we got going on there? That is about right. Let's see, I'm going up by 9, I'm going up by 15, I'm going up by 21, going up by 27. It's going to work out to be quadratic, but I would not have expected you to notice that. They would have, quadratics have this thing called a common second difference, and I'm not going to go too nuts about that because they don't talk about it in the course. But they're giving you a very small part of the graph. They're not, in other words, if I was looking at the graph here, we're used to getting the pieces from here to here where you can see the symmetry. They're giving you the piece from like here to here. All right, that's why it's unrecognizable to you. I wouldn't worry too much about it. Okay, find how was I able to understand it? This would be second differences. This would be common ratio, and then the first one, A, would be a common difference. Write a symbolic representation. This would be you could do it a few different ways. A sub 1 is 5. a sub n plus 1 is a sub n plus 2. This one would be a sub 1 is 6. A sub n plus 1 is 9 divided by 6 is 1.5 times a sub n. And this one I'm not worried about showing you how to come up with that. It's a whole lot of work for something they will not, absolutely will not put on the regions. And then graph your data. I'm sure that you could graph the data. Okay? Any questions? Okay.
Wait, we missed a question.
But did we? I'm sorry.
The factors.
Oh, factor. Again, factoring such a basic fundamental skill. X minus 4 times x plus 2. Are we good? Nice. It would make more sense to say float your totes.
Float your totes.
Yeah, a tote is like a bag. So if you like went overboard, your bag could float.
But once again, I'm not talking about a bag. I'm talking about like totes as a total.
Oh.
I told you.
We've been over this before.
I thought you used to say float your goats.
Yeah, I know that's what you thought I said, but I said totes.
I still thought you said goats again this time. I really
I
do.
say goats.
Anyway, you know, it's so funny. I prayed for sons. Because if worse came to worse, I could just smack them. I can't smack a girl. I cannot hit a girl. Girls are cherished. Girls are precious. Girls are not to be hit. You other girls might not feel that way, all right? But I, as a guy, definitely feel that way. And I was raised to be very protective of girls. And then I coach softball, and I am in love with my softball team every year. I am super, super, super protective of them. I am so glad I have them in my lives. It's kind of like for a short period of time, I know they're not my daughters per se, but I do feel a little tiny bit of a family connection there. I really, really, really enjoy it. And then there's Phoebe. And Phoebe kind of, when she keeps trying to explain about totes and goats and everything else, I just say, you know, Bob, at least you didn't have to deal with that growing up. If my son would have tried to explain this to me, I'd have said, shut up. That's not, I don't want to hear it. Enrique is a biologist who has been monitoring the population of a rare fish in Lake Placid. That's kind of humorous because there's a movie called Lake Placid where they have this crocodile in there, and which is what's really funny about that is Lake Placid is upstate. They actually held the Olympics there, the Winter Olympics, and it gets frozen and multiple feet of snow up there all the time. So you could not have had a crocodile in Lake Placid yet. The movie was all about that. He has tracked the population for 5 years and has come up with the following estimates. Create a graph and a function to model this situation and use it to predict, assuming the trend continues, when the population will leave the system. Dun, 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 dun. Let's see if I can fit it all on the screen using 100%. I can maybe. Oh, look at that, I can.
But you're skipping 2002.
There we go. Okay, so let's label the graph first. We have 0, and the population goes up to 1,000. So let's see here. 1, 2, not tens. 2, 4, 6, 8, 10, 12, 14, 16, 18, 20. Good. We're gonna do it by 50s. 100, 200. This will be 300, 400, 500, 600, 700, 800, 900, and I'm off by a line. 100, 200, oh, this should be the 300. The 400 would be here, the 500 would be here, the 600 would be here, isn't this ugly? The 700, the 800, the 900, and this would be 1,000 up here, 1,000. Okay. All right, and going across the bottom, I'm going to use the numbers 1, 2, 3, 4, 5, and so on and so forth. And I'm going to move them over 2 spaces because I can space it out a little bit. 1, 2, 3, 4, 5. And we all understand that the 0th year is 2002, this is 2003, 2004, 2005, 2006. I won't need that one. Okay, so let's plot the graph now. 2002 is 1,000. 2003 is 899, so this is 900. So 2003, which is the first year, is right about there. And the next one is 796, which is right about there. And the next one is 691, which is right about there. And the next one is 584, which is right about there. And now I'm going to do my best to connect the dot. Now, these are not in perfect alignment, but it's pretty good. All right, so let's see, this is 2006, 2007, 2008, 2009, 2010, 2011, 2012. If I just carry the graph through, there'll be no fish left in the lake. Okay? Questions? Okay. Very good. Homework is the only thing left. So, chew on that work this weekend. We need to get better.